Hello, my name is Balaji. I am going to speak about the topic time dilation. This was originally said by the scientist Albert Einstein. Okay, but unfortunately he didn't receive the Nobel Prize for this, but he received it for the photoelectric effect. There are two parts of relativity. One is the special theory of relativity, another one is general theory of relativity. This comes under special theory of relativity. I am going to explain time dilation. First, what is time? Time is the difference between any interval of what is happening. This is one interval and this is one interval. So this is time. So how did they define a unit for time? For example, if I say this is 1 second, okay, can you take that as 1 second? Because whenever I am going to tick like this, it may not be 1 second. Sometimes I may tick like this. So there is no consistency. That is why they are dependent upon atomic clocks, which do not change up with respect to time. So this is time, as I given the definition. So what is dilation? Dilation means getting big. That is dilation. Okay. So what happens? First, as I said, this was explained by Einstein. So what happens is when an object is traveling near the speed of light, it appears as if it takes a longer time for the clock to tick or anything to happen. That's what time dilation is all about. So why does this happen? I'm going to explain with this experiment. Okay, consider two spaceships, one and another one here. Okay, and this spaceship sends light beam here and this reflects it back. This is what an observer inside both spaceship would observe. But when I am here at a distance from the spaceship, this is the light when the observer is in the spaceship. But if I am here, very far away from the spaceships, I will observe a light like this. That's why. That is, I will observe that light is taking a larger distance. Instead of taking the straight line, initially it will go like this. But when I am observing, the light will be somewhat tilted. This accounts for the extra time. Actually, time is always constant. Time is fixed, not fixed. It can go. If I am doing this, this is time. When I am not doing this, still it is time. If the clock is ticking, is it not time? So time is not what? Time is not fixed. It is free to do anything. That's all. So what does Einstein say? He says that when an observer observes another spaceship traveling very close to the speed of light, 0.9 c. What is this? 0.9 c is nothing but the speed of light. So what that is 3 multiplied by 10 power 8 meter second inverse. This is the speed of light. So at high speeds we cannot imagine, but when we are traveling, it is very slow. We are traveling about maybe 2 kilometers per hour. That is very small when compared to this huge speed of light. But when an object is traveling very close to the speed of light, these effects will be more pronounced. That's what Einstein said. Actually, nothing physical is happening. So that's why I'm saying you cannot really slow down time. Okay, for example, when you are watching a movie in a recorder or something like that, you fast forward it and do all those things because that is fixed. But really time is not fixed, so you can't do anything. That's what Einstein said. And he also gave one equation about this. That is this T is equal to T naught phi root of 1 minus v square by c square. V is nothing but the velocity I am or any object is traveling. C is as usual is the velocity of light, that is constant. What he says is the time I am measuring at rest, that is T naught, is equal to, the time I measure when I am traveling at a velocity v is equal to the time at rest divided by square root of 1 minus the velocity I am traveling divided by the velocity of light whole square. That's what Einstein said. He gave a very simple expression. And I also like to discuss about the twin paradox. That is, if imagine two twins are there on planet Earth. Okay, one twin is going somewhere to any other galaxy near the speed of light, as I said here, and he comes back. Many people say he will get younger. Actually, what happens is, according to my view, we assume that he is younger. Actually, when he is traveling, due to this time dilation, he will say that the time I recorded was very less. Actually, what happened is, both of them are in the same age only. That's what is happening in this time dilation. But Einstein also said that time is not absolute. That means there is no absolute measurement of time. There is no absolute measurement of time. He didn't say there is no absolute time at all. So I may measure the time at somewhat 3 hours. Another may measure that as 3 years. 3 hours and 3 years. But time is always the same. He said there is no absolute, no constant measurement of time. So, thank you.